Okay,
Oh,
so,
I have one more question. I'm sorry.
okay,
Um, so if you don't do, like, if you're doing some fractions, if you don't do the factors, then you'll get the answer wrong. Is that right?
you have to show me which kind of problem.
So I did one wrong, and it was like, let's say it was 5/2 divided by 1/4 plus 13. Was that the one that I got wrong? Wait. I don't know what I'm sorry. I
Okay,
wrote down
try,
something.
I'll hang on to this.
Okay,
And when you, before we're done, we'll do that.
that sounds good.
I think you were asking, do you have to prime factor everything to get it right? And the answer is no,
Okay,
you don't have to.
okay.
But occasionally, it's to your best advantage to do it.
Right, right.
So it's just a tool, you know, you use it when you need it.
Okay.
So what I'm going to do is, this is 3.1. And again, this is not on the test. So I'm just going to get you started with this so that you'll understand. There's a rule in mathematics that I really haven't seen too often written down, but here's what it amounts to. To add or subtract, okay, you must have like things. Now, this is so basic that they don't bother to mention it. But I want you to know this because it has to do with fractions. When we get to fractions and we try to add 1/3 and 1/4, we cannot add them because we don't have like things. This is in thirds and this is in fourths. So when you add or subtract, we're going to need a common denominator. Now, we don't need it for multiply and divide. We need it for adding and subtracting. And so we did a little bit of this when, I don't know if you remember, we did some problems like this, where they said, well, which one is the biggest and which one is the smallest? And you had to stack them. Well, from this vantage point, we can't tell very well, but we can tell once we have a common denominator. And then it's really, really obvious which one is the biggest and which is the smallest and which one goes in the middle. Now, I didn't want to redo this problem, but I wanted you to remind you that the way we determined which one was the biggest and which one was the smallest was to get a common denominator. So let's see, some of these you know. And so if we're going to add, and let me start with this. Well, once in a while, they give you a problem like this, and you should say, thank you very much, because the denominators match. And so when they match, life is good and you're ready to add. And so all you have to do is add the numerators. 1 + 2 is 3. The common denominator is 4. So anytime you get that, and subtraction would be the same, if the denominators match, then life is good. But let's move that off the screen and look at a different problem. Now, I want you to notice, when I'm adding, I tend to write my problems vertically like this because I've got to turn them both into a common denominator. Now, it may be obvious to you what the common denominator would be. It's a number that both could multiply into, and it's also the lowest. Do you know what it is?
12.
It is 12. So we're going to start with some where I think it's fairly easy to guess. And in this particular case, not every one, we multiplied 4 times 3 and we got 12, and that'll definitely work, but it may not be the lowest. So here's what I want us to do. Here's 4, and we're going to make an equivalent fraction. So 4 times 3 is 12. But what I put here, I have to put here. So that 3 over 3 is 1, and I haven't changed this. So 4 times 3 is 12, 1 times 3 is 3. We've already done this making equivalent fractions. In this particular problem, I've got 3 that needs to be a 12. And so the factor that we need is 4, and so it's 4 over 4. So this technique will work here and also in algebra. So this is why I'm teaching it this way. 3 times 4 is 12. 1 times 4 is 4. Whereas this wouldn't work, this will. And so I have the matching denominator. So it's going to be 12. And all I need to do is, because it's add, 3 plus 4 is 7. Now, this number here may reduce like we've done before, where we divide both by the same number, but this one will not reduce further. So this one is finished. Now, I believe when they taught you fractions, they made them just so hard and then they stopped. And so I'm going to keep upping the ante. So I'm looking at this one. Now, in a class of, 20 or 30 people, a few people could guess the answer, and maybe everybody could guess the answer. But there's got to be a way to do it when you can't guess anymore. And so what I'm about to do is start to show you a couple of ways to guess. Now, multiplying 6 times 8 is 48, but that's too big. And when you work with numbers that are too big, you give yourself extra steps that you don't really want or need. Does anybody know the correct common denominator?
24?
It is 24. So this may still be guessable. Now, it's so frustrating in a class where somebody sees it and the other people don't. Do you know what I'm saying? It's like, darn that, that's not fair. So I'm going to show you the first way that you might be able to figure this out. I would start with the larger number. And this is called multiples. And so the larger number is 8. And this is where knowing your multiplication facts helps. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And they keep going up. I'm going to do the same with 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. Why did I stop here? Because this was the first time we had a match. Both the 8 could go into 24 and the 6 could go into 24. Now I started with a larger number because I get there quicker. So if the numbers aren't too big, and I would say in this particular example, they're not too big, this doing multiples might be a way to do it. And so let's finish this problem so you can see it. 6 times what? See, this is your multiplication facts to make your life simpler. It's 4 over 4. I put the dot in there to remind me this is multiply. 1 times 4 is 4. But with the 8, to go to 24, it needs to be 3. 1 times 3 is 3. So this is adding. I've got a common denominator, 24. And it's add 4 and 3 is 7. And this one is done. The reason why some people could make a decent guess and others couldn't, I believe, has to do with seeing into these numbers. And so I'm going to look at, I want to show you something else that has to do with prime factors, 1/6 and 1/8. If I look at the 6, okay, 6 is really 2 times 3. Right? Prime number, prime number. 8, well, 8, if you do it out one way or the other, 2 into 8 is 4. 2 into 4 is 2. And so 8 is really this, 2 times 2 times 2. Let's check. 2 times 2 is 4, times 2 is 8. These are the prime factors. When you go for the lowest common denominator, which is also referred to as the least common multiple, you've got 2's and you've got a 3. This answer, your best denominator, your lowest denominator, has to do with these factors. And so as far as the 2's are concerned, we have 3 here and 1 here. We have to take the most. So as far as the most is concerned, it would have to be 3 of them. There is a 3 here, but not here. It doesn't matter. We have a 3, only one of them. So the most 3's would be 1. So 2's, I have to take the larger batch, and 3's, this is larger than nothing. So this is my answer. But what is this number? This number, 2 times 2 is 4, times 2 is 8. 8 times 3 is?
24.
24. So when life gets more difficult and the problems are not so simple, the numbers are not so easy to find a common denominator, this is when I go into prime numbers, because this will nail it perfectly every single time. Should I do it every time? No. Sometimes I can just plain guess. And if I can see the answer, why should I bother? Like that one, or like this one. I could see it's 12. Why make a fuss? Right? If you can see it, just do it. But honestly, I believe teachers, because they didn't want to go into prime numbers, they just kept the problem small enough that you could still guess fairly easily. And now I'm here to tell you now what happens when it gets worse. And that's what I'm interested in. What happens when the problems get harder? Well, when the problems get harder, this nails it every single time perfectly, perfectly. Okay? So we don't have to do it every single time, but we definitely need to be aware of it. Now, I don't know if anybody started these problems, but I definitely want to. So one of the jobs they ask you to do is they give you a couple of numbers and they say, well, find the least common multiple, which is also the lowest common denominator, in case anybody needs to know. So here's a question that's asked. Find the least common multiple, and they use it because it's so much quicker to say LCM, of a 2 and a 5 and a 10. Okay? So what that really is saying is if you had a problem like this, what would be the common denominator, the lowest common denominator? Can anybody see it without a fuss? What number could every one of these move into?
10.
10. And so the first thing you do when you have to find a common denominator, or in this case, they didn't even want you to add them, they just wanted you to tell what the common denominator is, the lowest, by the way. The largest number may be the answer. So if the largest number is good for all of them, then your answer is 10. Okay. Here's another one, and we've actually done this in the least common multiple of 8, 12, and 24. If you need to visualize this, and I'm just making up numbers, which number could all three go into?
24.
It is 24 again. And so that's fine with me. Now, least common multiple of 12 and 18. So this is as if you had to add these and you needed a common denominator. Now it's not so easy. Or maybe somebody can guess. See, that's what's unfair. Some people can guess and some people can't. So what am I doing? I'm showing you how to guess, not guess anymore, but actually get it.
Is that 3?
It has to be as large as the largest one.
Oh,
So it has to be at least 18, but the trouble is 12 doesn't go into 18. So even though it says least common multiple, we're looking for a number that's as big as the biggest or maybe bigger. And it's going to be bigger because 18 isn't good enough. Okay. So I've got two ways to do it. I'm going to start with the 18. If you can do multiples of 18, 18 times 2, anybody know that? 18 times 2?
36.
36. Well, does 12 go into 36?
yes.
Yes.
It does. So this may short circuit some of your work. Okay?
Yeah.
This may have done it. Now, let's look at the prime numbers. I'm going to look at 12 and 18. And I'm going to do them both. And 2 into 12 is 6. And 2 into 6 is 3. So that's what 12 looks like. A 2, and a 3. Now I'm going to do 18. 2 into 18 is 9. Now 2 doesn't go anymore, but guess what? 3 and 3. So 18 is really 2 times 3 times 3. To get the least common multiple, which would be the common denominator, which we know the answer already, you see that you have 2s and 3s. As far as the 2s are concerned, there's 2 of them here and 1 of them here. I always go for the most. So I would have to take 2 2s. As far as 3s are concerned, I have 1 here and 2 here. I'd have to go with the most because you've got to cover it. This is the answer, but let's see what the answer is. I could do this multiplication one at a time, but I'm starting to remember that commutative and associative property, and sometimes life makes it easier. 2 times 2 is 4, 3 times 3 is 9. Guess what this number is going to be when I multiply it out? 36. So this nailed it. This approach nailed it. But this, it just so happened that multiples got there quicker. By taking the larger of the two, the largest one, and doing multiples, I hit the 36 in nothing short of 5 seconds. And then I knew what to do. And so the answer for this, what's the least common multiple? The answer would be 36. They both could be multiplied into 36 perfectly. How's that? Questions?
Does that work for multiplying multiple fractions or like adding multiple fractions together? Like if
It
you had like
works for
5,
any adding of fractions.
okay. All right.
So the question, let me see. Let's see. They're asking you to find the least common denominator, which we also know is the lowest common multiple. It's the number that would be used to add them together,
18.
18. I don't like 18. 4 doesn't go into 18. What about
12.
this? Yeah, 12 will do it. And how did I get it? I used my multiple method. 6 times 2 is 12. 2 goes into 12, 3 goes into 12, 4 goes into 12, and 6 goes into 12. It's 12.
Wow.
The numbers are small. I used multiples. How's that? Has anybody worked on any of these? I know it can get worse. I'm going to do this one. Least common multiple of 42 and 70. I have no idea the answer is this, okay? I'm not even going to guess. Because the numbers are so large, I'm going to prime factor it. And this is the advantage when you write your work on a test and I can see your work, then I can see if you're halfway there, you're halfway there. But what needs to be done in each case, I'm losing people. In each case, you need to prime factor it. So 42 is even, so I'm going to divide by 2. 2 into 4 is 2. 2 into 2 is 1. 2 does not go anymore, does it? But 3 goes into 21, and so about 7. So 42 is really a 2, a 3, and a 7. Okay? Now I'm going to do 70. This is even, so I can divide by 2. 2 into 70 is 35. Now 2 won't go, and neither will 3. But guess what? 5 goes. 5 into 35 is 7. So here's what 70 looks like. Believe it or not, a 2, a 5, and a 7.
Hmm.
These are the skeleton views, and it'll take us a while to get used to this, but I want you to see this is the way in. And some of you I haven't seen, but most of you I assume are reasonably young. They may have taught you prime numbers, but there was a time when they just thought, oh, it's so hard. We can't possibly ask students to learn this. And so nobody could get it because this was the clue that they needed. This is looking at the numbers. Now, you have a 2, 3, 5, and 7. So as far as 2s are concerned, there's 1 here and 1 here. So the least common denominator or least common multiple, I just need a 2. There's 1 here and there's 1 here. So the most I have is 1 in a single line. As far as a 3 is concerned, I only have a 1, but I have to include it. As far as 5s are concerned, I only have a 1, 5. And there's a 7 here and a 7 here, but I only have 1, 7 and
Mhm.
1, 7. So I only need 1.
Wow.
This nails it. This is the perfect answer, the lowest one, guaranteed. And guess what I'm going to do? Remember how I've been multiplying things to make my life simpler? I've had decades to figure this out. 2 times 5 is 10, right? 3 times 7 is 21. Now you could do this inch by inch by inch, but this is so much easier. 21 times 10 is just 210. That is the number. And nobody would have guessed that. I couldn't guess it. Well, maybe I could, but I don't think so. I haven't had enough caffeine.
Ah,
Okay? I'm still a little tired. But that's the exact right answer. And this was a problem that would have been too hard when you took courses before.
yeah,
Wouldn't have expected this. But I'm here to say we can't play, let's just do little problems because life is so easy. You know better than that, don't you?
yeah,
Sometimes it's tougher. So what do? You pull out the heavy artillery, right? And this will work. I'm not expecting you to grab this the very first time, but you will eventually get this. And I think with the multiples, you may very well be able to short circuit all this. This is not used every last time. This is used in emergencies, okay? All right. Any question about that? So we're just trying to get you started. And I know I've lost a couple people already, but that's no way to go. You need to hang in there.
yeah. My
You need to
Catholic
hang
school
in there
didn't.
because just because it looks hard, it's not, I'm convinced you can do it. Okay? I'm convinced.
I didn't do my last homework because I got frustrated.
Yeah, and this is, and so what I've said to people that I've talked to individually and also in class is that I'm available most days of the week. So
Yeah,
just send me an email at the end of the day and suggest a time or two where you could meet,
okay.
and that's it. And
So-
we'll straighten this out quick as can be.
I tried to use Trio, but they weren't available.
Oh, okay, well, maybe there's a better way. I'll check on that. But just send me a message through XYZ. So
Okay.
here's a subtract problem. Can anybody, again, I'm going to write it vertically. 2/5 minus 1/6.
30.
It is 30. And so when you can see what it is, don't fuss, just do it. But I think getting in the habit of showing the number, if you make a mistake, you'll be able to see what happened and what went wrong. So what's the missing number here to make 30?
3. I mean, 6.
It is 6. So this is 6/6. So this is 30. 2 times 6 is 12. I do the same with this number. 6, what's the missing number? 6 times what? What is it?
5.
Correct. So this is 5/5. So the dot 1 times 5 is 5. This is subtract. Don't add by mistake. 12 take away 5 is 7. And the common denominator is 30. So you're not going anywhere until you get it into a common denominator because of the rule I said. If you want to add or subtract, you must have like things. This applies to all of arithmetic, all of algebra. Instinctively, you know it. When you had 3 inches and let's say 4 feet, and you wanted to add them, but they're not like. You do not get 7 something, do you? You can add 3 inches and 4 inches to get 7 inches, but you can't add unlike things. So adding and subtracting requires like things. In fractions, it requires the common denominator. So add, subtract, common denominator, multiply and divide, whatever. We multiplied any darn thing by any darn thing and divided, and nothing went wrong. But with adding and subtracting, you've got to get this match. And so, I mean, people get confused about that, but that's what's going on. Let me see if I can find a different one. Let's see if I can find this. I'm trying to see if you, this is a pushy one. It's a 16 and a 12. We may have to go to prime numbers, but we may not. Let's see if we can short circuit this. Do the multiples of 16 because it's the larger of the two and we get there quicker. 16 times 1 is 16. 16 times 2 is 32. And I know these for a fact. 16 times 3 is 48. Well, any of those numbers work as a common denominator.
48.
48. So this is a legitimate way. This is least common multiple, and these are all multiples. And so there's no reason, but don't do them both. Work with the larger one so you get to the answer sooner. This is 48. And what you've noticed is 16, it was 16 times 3. Okay. Now I'm going quicker because I do know them, but 16 times 3 is 48. 9 times 3 is 27. 12 goes into 48. It's 4 times, right? 12 times 4 is 48. We get better as we start remembering all these things. And then 7 times 4 is 28. We've got our match. So the answer will be over 48. And what I have to do is add 27 and 28. So this looks like 15, carry a 1, 5. And once in a while I get tired and I make a mistake. So tell me right off the bat if you see a mistake. But I think that's pretty good. So is this done? Okay. It looks like the book or the XYZ homework is accepting answers like that.
Okay.
Okay. And how do I know this doesn't reduce? Because 55 is 5 times 11. Right?
Mhm.
Is there a 5 in 48? No. Is there an 11? No.
No.
Done.
Oh, okay.
You see the prime numbers give you the insight to not make mistakes anymore. Did you see what I was saying? 55 is 5 times 11. If I don't have a 5 in this factor and I don't have an 11 and I don't, then that means that this is done. It couldn't be reduced anymore. We don't have a common factor anymore. How's that?
Great.
That's a little bit pushy, but that's what I'm interested in. So that's, like I said, it's going to take us a little while to get used to doing fractions, because if I had to guess, if somebody had trouble with arithmetic, I would guess it had to do with that lesson right there. There's other things too. People have trouble with percents. But adding fractions and getting a common denominator is one of the things that finish people off. Okay? So let's see what we can do. We still have a bit of time. Does anybody remember any question from chapter 1 and 2 that we could go over, or we could look at the review questions. Anybody see anything? How about that problem that we looked at toward the beginning of class? Anybody? I'm going over to XYZ. Okay,
Pull on mine. I did pretty bad.
say again.
I said, pull my homework out. I did pretty bad.
Okay, well, what we need is what kind of problems? I
I
mean,
didn't write it down.
oh, okay, well, that's what we need to do in the future is write things down.
Okay.
So people worry about tests, and I always drop the lowest grade of a test, but try not that, have it be the very first test. But this review work that was at the very bottom of XYZ, this is what you should look at between now and Wednesday. The area of a rectangle, what do you need to do with the width and the length?
Multiply by 0.5.
Multiply 3 times 6, right? Because it says the width is 3 and the length.
Oh,
is
rectangle. Yes.
Yeah, just multiply, so it would be 18.
I was thinking triangle.
Oh, yeah, that's right. This is the square, but one side, the perimeter. So do you need to see this on paper? Because it would be a good idea to draw yourself a square, but perimeter is not area, it's going around the very edge. What would the answer be?
9.
More
No,
than, no, it's not multiply.
4.
I'm going to let this person in, and then I'm going to go back to paper. I'm going to stop the recording. Let me see.